Hello everyone, this video is a continuation of our discussion about subtraction algorithms. Okay, so this image shows the development of the standard subtraction algorithm. Alright, so the problem is 423 minus 157. Okay, so you can see that this problem does involve exchanging or regrouping. Right, if we start out with 3 minus 7, we don't have enough ones to do that. Okay, here's what this looks like in base 10 pieces. You kind of have to ignore their exchanges at first. They showed this all at once, so let's ignore this. Okay, but here we have 4 flats, okay, 2 longs, and 3 units, so that's 423. Right? Now if we try to take away 157, right, what you want to do is think, first of all, think about the ones, think about taking away 7 ones. Well, we can't do that since we only have 3 ones. And similarly, if we try to take away 5 longs, we can't do that since we only have 2 of them. Right? So that kind of shows the need for exchanging or regrouping. Right? So we don't have enough longs or units, so we want to exchange 1 long for 10 units, and then we don't have enough longs to exchange a flat for 10 longs. Okay, and then you get this grouping here. That's what you end up with. Right? Now the taking away, now we can do this. Right? So you circle to take away 1 flat, 5 longs, and 7 units. And then whatever is left is the answer to that subtraction problem. 2 flats, 6 longs, 6 units, so 266. Okay, 266. Okay, here's what this would look like using a chip abacus. All right, so you represent your first number, 423. Okay, 4 chips, 2 chips, 3 chips. We need to take away 5 and 7, but we can't. We don't have enough. So then you make your 2 exchanges, 100 for 10 ones, and then 110 for 10 more ones. Okay, and now you can subtract, so circle to show the ones that are being taken away. Alright, 100, so 1 chip in the hundreds column. Okay, 5 10 chips, okay, and then 7 chips representing 1. And then the number that is left in each column that's not circled, that's what's left, so 2, 6, and 6, which represents 266. And then finally a place value representation. Okay, so here's the original problem, and it's clear from seeing this that we can't subtract 3 minus 7 or 2 minus 5. We don't have enough 1s or 10s, so we do regroup. Okay, it's like borrowing, but instead of writing the number kind of at the top like you would with a standard algorithm, you actually add it into the next column. All right, so we're going to borrow 110 from 2 10s, and then we add that 10 to the 3 1s in this column. So 13 is 10 plus 3. Okay, and then we're left with 1 in the 10s column. All right, and we still can't subtract 1 minus 5, so then you borrow 1 from the 4. Right, and that 1 is a group of 100. Okay, so that's 10 10s, so it carries over as a 10, and then this 11 is really 10 plus 1, and then you can subtract. Right, so very similar to the standard algorithm, but just written without the little tiny ones that were carried or that were borrowed. All right, one more example. Find 52 minus 38 using base 10 pieces. Okay, so let's represent this. I'm sure you can do a better job of drawing this, but just here's a quick rough sketch. Okay, so, 52, not 500. Okay, so 5 long pieces. I think I'll just do lines. 2, 3, 4, 5 longs and 2 units. Right, and then I need to take away 3 longs and 8 units. Okay, so I have enough longs, but I don't have enough units. All right, so next image I would show the exchange of 1 long for 10 units. Right, so that leaves you with, okay, these pieces are still longs, 4 longs. and then that fifth long becomes 10 units. Okay, 10 units, and then I still have my 2 units from before. Okay, and now we should have enough, so circle to show subtraction or taking away. You want to take away 8 units and 3 longs, and then see what's left. Okay, so there's 1 long, and there are 4 units left. So the answer would be 14. 14. Okay, similarly, we could show this using a chip abacus. We've got tens and ones. We have 5 tens, 2 ones. Okay, take away, can't. Right, so next image. Okay, exchange 1 chip that represents 10. So I'll only have 4 left, and exchange one of those 10 chips for 10 1 chips. 10 chips representing 1. Right, and I still have the 2 from before. And then take away 38, so 3 chips in the tens column, 8 chips in the ones column. Okay, and that leaves you with 1 remaining here, 4 remaining here. So the answer is 14. All right, one other algorithm that you may not have seen before. This one is called subtract from the base, and the gist of this is that we want to subtract from 10, right, which is a little bit easier than trying to subtract from any given number. And recall that 10 is the base of our system. That's what we group by. We group by tens. All right, all of the place values are based on powers of 10. All right, so here's how this works. It looks similar to the standard algorithm. The only thing that's different is kind of the order in which you add when you do the borrowing or exchanging, right, and the subtracting. Okay, so 323 minus 64. So you do 3 minus 4 first. Okay, we can't, so you want to regroup one of the tens, right, that leaves 1 10 left, and carry it over as 10 1. So that gets written up here. Notice we wrote 10 instead of just carrying a 1. So that's a little bit different than the standard algorithm. All right, and then now, normally in the standard algorithm, you would add those. You would think of that as 13, and then you would subtract 4. Okay. But in this, we're just reversing the order. So instead of doing 10 plus 3 minus 4, okay, or 13 minus 4, we're just switching the order of the addition and the subtraction. So you're going to subtract from the base, subtract from 10, and you're going to do 10 minus 4 first, and then go back and add the 3. Okay, so 10 minus 4 is 6, and 6 plus 3 is 9. All right, and this is kind of nice because if you don't have to learn that fact 13 minus 4, sometimes kids are more comfortable with the subtracting from tens because they're comfortable with combinations to 10. All right, so that gives you the ones. All right, and then notice in this algorithm, your book's just writing below kind of the order in which that process has been done because it does look so similar to the standard algorithm. So that's showing the difference at the bottom. All right, now to subtract the tens column. So right now we have 1 minus 6, which can't be done, right? 1 10 minus 6 tenths. So you exchange 100 for 10 tens, and that gets written as a 10, not as a little tiny 1 that was borrowed. Okay, so now you're left with 2 hundreds, right, and then 10 tens. All right, so in the standard algorithm, you would add this first and think of this as 11 minus 6. Right, now in the subtract from the base, you do the subtraction first before the addition. So you're going to do 10 minus 6, and then go back and add the 1. Okay, 10 minus 6 is 4, 4 plus 1 is 5. And then finally the hundreds column, 2 hundreds minus 0 hundreds is 2 hundreds. Okay, let's try one more example. 527 minus 48. All right, 7 minus 8 can't be done. Exchange 1 10 for 10 ones, and that leaves you with 1 10 remaining. Okay, then we have basically, normally this would be 17 minus 8, but now we're going to think of this as 10 minus 8 and then plus 7. Okay, so if you use this algorithm, it'd be a good idea to just write below what order this was done in so that it's clear how it's different from the standard algorithm. All right, and then that's 2 plus 7, and that's 9. All right, then moving on, let's do the tens. Okay, 1 10 minus 4 tens, we need to exchange. So exchange one of the hundreds for 10 tens, and that leaves you with 4 hundreds. Okay, then here we should do 10 tens minus 4 tens, and then add the 1 10. So that's 6 plus 1, which is 7. And then finally the hundreds column, 4 hundreds minus 0 hundreds is 4 hundreds. Okay, that's all I want to say about the subtraction algorithm, so we'll stop there, and I will see you in the next video where we talk about multiplication and division algorithms.